Now I'll move on to a test showing where there should be a collision. So I'm going to pause again while I find the appropriate ray, which is a ray with a direction of minus 0.24, minus 0.12, 0.96, and I'll do the same process there. Right, so I'm now on the ray with a direction of minus 0.24, minus 0.12, minus 0.96, as described here. So this ray should collide with the sphere, and it should continue on past where the previous ray hadn't. So beginning to pass through this again, I am already on the collisions method. So again, the first few lines are all just assigning variables, which are very obvious to read. So checking again that cam rotation does return the right value. Again, should be 0, 0, 0, like before. Continuing down, cam ray direction. Oh, typing in the wrong section. Cam ray direction again should return the same as the original direction, which it does, possibly with some minor accuracy changes. So again, the first object should be the sphere. Object.getRender should return true. Again, true. Object.rotation should get the rotation, which again is 0, 0, 0. 0, 0, 0. Continuing down. So the object ray direction should be the same as the original. I'm just going to do this. So it should be the same as the original direction, which it is. Same for the origin, it should be the same as the original origin, which is 0, 0, 0. Oh, I haven't defined it yet. So that should now return 0, 0, 0. Again, skipping through to the if statement to check if it's a sphere. Object._get_type should return false, as it did before. Position should be 0, 0, 8. We've already tested this, so I'm not gonna go through it again, but I will go through the A, B, and C. So as you can see, A is 0.476 this time. If I scroll down, I should find it's about 0.474 here. Again, because of rounding, it won't be exactly the same. Continuing down, I'll just skip through C and then look at B at the same time. So B is minus 3.845. Here I have it as minus 3.84. C is 32 again, which again I have it here. Checking the discriminant, here it is 0.03216. I have it as 0.0516, which is likely down to the slight changes in decimals, or possibly an error on my part from reading it from my calculator, but I think it's more likely that it's down to the decimals, which means the discriminant is greater than 0, which means that if statement gets evaluated to true in this case, which means it can now calculate the distance, which if I run through it again, it gets 7.89. I had 7.86, so again very similar, likely down to a rounding error. The minimum, I think I skipped past that, the minimum of 7.89 and infinity is 7.89, so the minimum distance becomes the distance, which is 7.862. Checking for the distance being equal to the minimum distance, you can see here they're both the same, which means that if statement gets evaluated to true, and it goes on to calculate the hit point, which I will now show. I think it won't be exactly the same, since there does seem to be a slight difference between the variables with what I got. So yeah, I had minus 1.89 and minus 0.94 and 7.45. It has minus 1.94, minus 0.97 and 7.58. So not quite the same, but again, very similar. So the normal will also be different then, because it's based off the hit point. So it has minus 0.88, minus 0.44, and minus 1.9. I think I've likely made a maths error here comparing those values. I don't think I've correctly calculated that, so I'm gonna pause the recording and just double check my maths. So I'm back. I have adjusted my maths. I had made a mistake. Those are the correct values. As you can see, the values I got are minus 0.87, minus 0.44, and minus 0.21, which are very similar here. So next, did hit gets evaluated to true, and the material gets evaluated to the sphere's material, which should be, I'm not sure if that was very obvious, but it should be, if I check now, material should be 0, yeah, which is what I had here. So those get returned. It's now moved on in the loop. There are no more objects. It will now go to the return statement and go back to the trace statement. Here, bounces get incremented by 1. Did hit is true in this case, which means the is specular now gets defined, which I wasn't previously able to define because it's based on a random value. So I will update my value here to whatever this random value is, and then do my maths and then compare again. So if I do is specular. So is specular is false in this case, or 0. So I will now do my maths, and then I will... Actually, I can't really do much until the diffuse vector has been defined. So I'll continue with that, and then again I'll carry on. So the diffuse vector here, if I show the diffuse vector, so that is the diffuse vector currently. I'm just going to skip ahead and show the diffuse vector later on when it has been returned. I might have gone too far. Oh well. We can now move on to the specular vector. So we know what the specular vector should be, because we have the dot product and we have the original ray direction and the normal. So here I found the dot product between the ray direction and the normal to be 0.06, and then the new direction to be 0.14, 0.067 minus 0.99. So we'll see if that is correct. So the dot product was 0.08, so again a little far off, but that's just due to the rounding being slightly different with my given values. So here it looks like the new direction is 0.08, 0.04, and 0.99. So again, close, not the same, but close because of the rounding errors from before. So continuing on, we know is specular is going to be 0, which means the roughness also gets evaluated to 0, which means the ray direction becomes the random vector, which in this case was I've skipped over. I might be able to go back. I don't believe I can. Anyway, I hope you can see that this is working. All the calculations are working. Thank you very much.